Have you ever looked up at a stormy sky and felt a sense of awe, maybe a little bit of fear? What you're witnessing is one of nature's most spectacular and powerful displays, a thunderstorm. But what's really happening up there, inside those dark, swirling clouds? How does a calm day suddenly turn into a dramatic light show? Today, we're diving deep into the electrifying science of lightning. It all starts with something you can't even see, warm, moist air. As the sun heats the ground, this air rises, carrying water vapor up into the colder parts of the atmosphere as it climbs. The water vapor cools and condenses. Forming tiny water droplets or ice crystals, these particles gather together, building the massive. Towering clouds we know as cumulonimbus or thunder clouds. But these aren't just fluffy water clouds. Inside, it's a chaotic world. Strong updrafts and downdrafts toss the water droplets and ice crystals around, causing them to constantly bump and rub against each other. Imagine shuffling your feet on a carpet and then touching a doorknob zap, the same principle, called static electricity. It's happening on a colossal scale inside the cloud. Through all these collisions, the lighter, positively charged ice crystals get pushed up to the top of the cloud by the updrafts. Meanwhile, the heavier, negatively charged water droplets and hail sink towards the bottom. This process, known as charge separation, turns the thundercloud into a giant natural battery in the sky. The top of the cloud becomes positively charged and the bottom becomes negatively charged. As the cloud continues to build up these massive electrical charges, the air around it, which is normally a good insulator, starts to break down under the immense pressure. The negative charge at the bottom of the cloud is so strong that it repels the negative charges on the ground below it, causing the surface of the Earth to become positively charged. Now you have a massive electrical imbalance between the cloud and the ground, and nature always seeks balance. This is when the magic, or rather the science, happens. The negative charge from the cloud base starts to reach down toward the ground in a series of short, invisible bursts called a step leader. It's like the storm is sending out feelers, trying to find a path of least resistance to the ground. As the step leader gets closer, the positive charge on the ground, attracted by the negative charge above, reaches up to meet it. This upward reaching charge is called a streamer, and it often comes from tall objects like trees, buildings, or even people. When the downward moving step leader and the upward moving streamer finally connect, they complete an electrical circuit. In that instant, a massive surge of positive charge shoots up from the ground to the cloud along this newly formed channel. This is the return stroke. That's what we actually see as the brilliant flash of lightning. It happens in a fraction of a second, but it's incredibly powerful, heating the air around it to temperatures hotter than the surface of the sun. This extreme heating causes the air to expand explosively, creating a shockwave that travels outward. When we hear that shockwave as thunder, since light travels much faster than sound, we see the lightning flash almost instantly, but the thunder takes a few seconds to reach us. You can even estimate how far away a storm is by counting the seconds between the lightning and the thunder. Every 5 seconds is about 1 mile. So, from simple water vapor rising on a sunny day to a colossal atmospheric battery creating a super hot channel of plasma, lightning is a breathtaking example of physics in action. It's a powerful, beautiful, and humbling reminder of the incredible forces at play on our planet. Next time you see a storm brewing, you'll know it's not just rain and wind, but an intricate dance of particles and charges, culminating in one of nature's most dazzling performances. Thanks for watching, and if you enjoyed this journey into the heart of the storm, don't forget to like, subscribe, and hit that notification bell for more deep dives into the world around us. Stay curious.